Bismillahirrahmanirrahim. Here, first of all, we are going to start our lecture with the preparation of alcohols. Then we will move towards the chemical and physical properties of alcohols. So, in the preparation of alcohols, we are going to prepare ethanol. So, through the chemical way, there are two methods through which alcohols can be prepared. One is chemical way and another one is biological way. So, if we will talk about the hydration of ethene, ethene will be hydrolyzed in the presence of steam. So in the presence of steam, it is going to form the ethanol. The reagent and conditions which are required for these reactions, for the reactions are number one, phosphoric acid. This is H3PO4 and 300 to 350 degree centigrade temperature. Temperature may vary, and you can get different temperatures are required, like 400 degree centigrade till 400 degree centigrade, but there are the ranges, but the most acceptable are 300 to 350 degree centigrade, and the atmospheric temperature pressure which are required is 60 to 70 atm. So ethene is going to prepare ethanol by using steam in the presence of phosphoric acid at the certain temperature, that is 300 to 350 degrees centigrade and 60 to 70 atmospheric pressure. Another way for the preparation of alcohol is the biological way, that is the fermentation. Fermentation. What basically fermentation is? A biochemical process in which microbes such as yeast act on carbohydrates under anaerobic conditions to produce ethanol and carbon dioxide gas. This is a process and biochemical process in which microbes like yeast act on carbohydrates, and carbohydrates maybe are starch solution, sucrose, maybe are glucose solutions. So carbohydrates family, if they act along with the yeast, then under anaerobic conditions. The meaning of anaerobic conditions, absence of oxygen. Then in the absence of oxygen, it will produce ethanol and carbon dioxide gas. So alcohols will be prepared in the presence of yeast in anaerobic conditions. So this is the way through which yeast can be prepared. If we will see what yeast will do, then the action of yeast is, what yeast is a biological catalyst. Enzymes, biological catalyst means enzymes which speed up the chemical reactions, right? So biological catalyst, enzymes which catalyzes the reaction. The enzyme which yeast have named as zymase. Yeast can respire anaerobically, means yeast can respire in the absence of oxygen. Then yeast works at optimum temperature like 37 to 40 degrees centigrade, and at a very high temperature till 60 degrees centigrade enzymes are denatured and reaction stops. So in your exams they will ask this question, that what happens when temperature will rise in this process of fermentation. Then in that case we can say that the temperature, because at a higher temperature enzymes are protein in nature, they will be denatured. So when the enzymes will denature, then reaction will stop. Another thing, yeast produce through this process it produces only 15 to 20% alcohols. In some books it is written 12%. So it depends upon the quality and the process through which it is going to be proceed. This process can be explained by using this equation. Glucose. Actually, what happens if we are going to describe this biological process chemically, then we can say that glucose, this is the glucose solution, C6H12O6 is the formula of glucose. In the presence of yeast, it will form ethanol and carbon dioxide gas. So when glucose in the presence of yeast produce ethanol and carbon dioxide gas, so there should be a way through which we can confirm that is this the gas which is colorless and odorless, is this the gas of carbon dioxide. Then we have a test with lime water. So after using this yeast in the absence of oxygen, don't forget yeast respire anaerobically. So in the absence of oxygen, Glucose will form ethanol and produce carbon dioxide gas. Carbon dioxide gas will be checked with lime water. It will turns milky. So lime water when turns milky means it will produce calcium carbonate precipitates after this chemical reaction. So this is the way through which we can get it, that how basically fermentation process is going to proceed. And there we can check it after having a look on this diagram. This is a process of preparation of alcohols through fermentation. Right, this is a process of fermentation. If we want to carry out this experiment and want to check, then there are some of the ways through which we can check how basically this process can be carried out. Sugar solution and yeast, we will take it in this conical flask, and again we will put it in the basin, water basin, hot water basin, or in the hot water beaker, where we will maintain the temperature till 37 degrees centigrade, and we will airtight it and insert the delivery tube in the lime water. Why we will use the lime water? Because for this experiment basically carried out in the absence of oxygen. So we have to make sure though no oxygen or air should be entered in this conical flask. So to make sure the precautions which we have to take, the rubber bung is skewed tightly to the flask, and the lime in the tube prevents air from entering the apparatus. So this lime water will prevent the air to enter in this apparatus conical flask. So it is very necessary for this fermentation process how it will be going to be carried out at 37 degrees centigrade, and to check and to ensure that no air should be there, because yeast respire anaerobically, and the meaning of anaerobically is the absence of oxygen. So if we will say the working of this in this graph, how speed of fermentation changes with temperature, we can check through this preparation how will we the speed through this graph, how we will check. So this side shows the speed of fermentation and this side shows the temperature. So if we will talk about the reaction, will start proceeding at the temperature between 30 to 40, which is going to work good. So the rate of fermentation increases, but after 40 it is the rate of reaction falls and slows down, and time comes that the reaction will stop totally. So this is the way through which we can express it through graph, the speed of fermentation, how it changes with the temperature. So at right after 40, if we will talk about the 40, right after 40 the speed will fall down. So this is the way through which the fermentation process carried out. Now next we will move towards our properties of alcohols. Okay. The first, the physical and general properties of alcohols. Properties of alcohol, basically alcohols are soluble in water. Solubility decreases down the homologous series. What does it mean? It means that methanol is more soluble than ethanol. It means our methanol is more soluble than ethanol. Then ethanol is more soluble than propanol. So it means that solubility decreases down the homologous series. Alcohols are liquid till decanol. And then ethanol, if we will talk about the properties of ethanol. But if we leave the alcohol open, then taste turns sour if exposed to air for long time. If alcohols for long times get the exposure to the air, then in that case it turns sour. The taste of alcohols turn sour. Why? I will tell you in the later property, chemical property. So if we will talk about the specific properties of ethanol, then they are all alcohols are non-electrolytes and commonly called drink. We will talk about the ethanol, commonly called drink, colorless liquid, neutral, less volatile, boiling point is minus 78 degrees centigrade, and highly inflammable. So alcohols can catch fire easily and used as fuel as well. Now if we will talk about the chemical properties. Chemical properties. Number one, which is very similar for the rest of the organic, rest of the homologous series, like combustion. So complete combustion. In the presence of plentiful supply of oxygen, alcohol burns completely to give us the product that are carbon dioxide gas and steam. For the incomplete combustion, it produces the carbon monoxide and steam. So this is a highly exothermic reaction. A lot of heat is produced, which is going to utilized in the which is going to utilize as a fuel in different vehicles. Can be used in a rocket and another mode of transportation and reactors as well. So oxidation of alcohol, another, if we will expose it to air, it turns sour in taste. Why? Because it is going to form a carboxylic acid, that is the ethanoic acid. So ethanol is going to form the ethanoic acid in the presence of air when certain bacteria acts on this alcohol. So this is a process through which it is little dangerous as well, because if you are going to take and if the people are going to take such kind of alcohols which turns into acid, that it can create such kind of problems in the health issues. So if we will talk about this is not the good to take if ethanol is exposed to you to become acid. It is poisonous to take this such kind of alcohols. Then by oxidizing agent. This oxygen can come from the air, or this oxygen can come from any oxidizing agent, right? That oxidizing agent, the two most common oxidizing agents are the potassium manganate, and we have to take a little acid in it. So acidified potassium manganate will gives us this oxygen. So alcohol will react with this oxygen, gives us ethanoic acid and water. Again, if ethanol is going to react with potassium dichromate, K2Cr2O7, this is the potassium dichromate, acidified oxygen will react with it. It is going to form the ethanoic acid. But the point is that this reaction is very, very much important for their color changes. The purple color of acidified potassium manganate, which turns colorless when reacts with the alcohol. So if alcohol is going to react with acidified potassium dichromate, then it will form ethanoic acid and steam. The color of potassium dichromate is orange and it will turn green. So potassium manganate, acidified potassium manganate and acidified potassium dichromate will have characteristic property of their color change. So these are the oxidizing agents. So then alcohols will react as the reducing agent. So this is a very characteristic property of the alcohol. The next chemical property, dehydration of ethanol, which we have prepared in the previous. If you can see, we have done this hydration of ethene. Through this hydration of ethene, ethanol was prepared. Now if we are going to take the same ethanol and heat it, it will again convert it into ethene and into steam. So it is used, this property is used to prepare the alkene. So another very important property is the esterification. Esterification, the functional group for esters. How can we identify what esters are? Whenever we have this C double bond C, O and this O in the chain, this one is C double bond O, O and O. This is the functional group of esterification. If we have this functional group in the chain, then we will say this is the esters. How we will prepare these esters? When carboxylic acid will react with alcohols, it will produce esters and water. Heat in the presence of concentrated sulfuric acid. Ethanoic acid will react with the ethanol at the concentrated sulfuric acid to give us water and ethyl ethanoate. But one thing we have to remember here, which is very important, that whenever we are going to react, a condensation take place, we will say this OH from the ethanoic acid and H from the alcohol will form the water molecule, and we will write it here like this. And now we will remove whole of this thing and condense. We will remove this and take this part, right? We will write this part here and write this part here. Okay. We are going to condense these two parts, then we will form the esters. So the point which is going to say ethyl, the point first of all we will name with the alcohols. So alcohol, if whatever the carbon atom is, if it is methanol, it will end up methyl. If it is ethanol, it will have ethyl. If it is propanol, then the name will be propyl. So ethyl, from ethanol to name is ethyl. First we will name the alcohol, and then the carboxylic acid part, it will be end up at ethanoate. So ethyl ethanoate is the ester which will form after the reaction of this carboxylic acid and this alcohol. So this is the way through which you can check that clearly. How will you prepare methyl methanoate? So before you have to draw this structure, pause the video, first draw it by yourself, how to draw methyl ethanoate. So methyl is the compound comes from methanol, from the alcohol. Remember, whenever you write this formula, C will be combined with O, not write the OH, right? O shouldn't be right here. Okay, so methanol, this is one is the methanol, and ethanoate from the ethanoic acid, OH from the ethanoic acid. So this is the way through which water molecule will come out. The rest of the compound we will write it here like this, and the part of the alcohol we will write here. The compound which will be formed, that will be the methyl ethanoate, right? One carbon atom with methyl ethanoate. So the another thing, so this one is basically is going to tell us that this is the functional group of esters, and it is going to tell us the compound is ester. So methanol and plus ethanoic acid will react together to gives us, this is a single bond, right, to gives us methyl ethanoate. If we are going to write this methanol here and ethanoic acid here, then remember we will switch the functional group towards this carbon atom, because it is going to be condensed by along with their functional groups. The OH from this and H from this will come out. The structure will be like this. So there is no matter, either you are going to write the carboxylic acid first or alcohol first, there will be no change in the naming. First we will write the name of the alcohol, and then we will write the name of the acid. So it will become methyl ethanoate. Methanol is here, ethanoic acid is here, so we will react it together to give this compound and water. So these were the chemical properties of alcohols. Now we are going to discuss the uses of these reactions of alcohols. So as fuels, due to highly exothermic reactions, alcohols are the reactions of combustions used to gives us a high heat. So as it is going to use as fuel due to highly exothermic reaction, as fuel produce less soot. So as soot it produce less soot. Less soot means the carbon content is less. It is eco-friendly fuel, because it is not going to produce any poisonous gases. So due to this reason, it is eco-friendly fuel. Alcohols also burnt our food to give distinctive flavors are different. Changes in color during oxidation, if we will talk about the color changes, so these color changes need in breathalyzers to see drivers have been drinking. So breathalyzers actually have oxidizing agent in itself. So if traces of alcohol present, then color change observed as alcohol as reducing agent in these reactions. So if we will talk about the uses of reactions, so these are the very important uses of alcohols. Now we have to look on the uses of ethanol, where basically ethanols are used. So ethanols are used, the very common use of ethanol is used in alcoholic drinks. So in alcoholic drinks, ethanol is used. Methanol is little poisonous. It is not going to be used in such kind of alcoholic drinks. So in alcoholic drinks, ethanol is used. Methanol is not favorable to use in the alcoholic drinks. So alcohols are very good solvent. They are very good solvent. Okay. Then they are used to make glues. They are used to make glues. So it is used as glues. It is used in varnishes. A number of uses of ethanol is there. It is used as in varnishes. Then it is used in perfumes. In polish. In making glows, varnishes, perfumes, paints. Ethanol. In aftershave lotions. Okay. And then in making esters. The very important one is in making esters. Esters are prepared through this ethanol when we will react it with carboxylic acids. Esters are basically a fruity smell. It gives the esters are usually gives us a fruity smell. It gives us a characteristic fruity flavor and taste. So another very important use, it is used as a fuel in motor vehicles. So these are the uses of ethanol through which we can understand the importance of this chemical. Okay. Then if we will talk about its manufacture, how it is going to prepare, industrial manufacture or on small scale. So talk about the manufacture of the versus if we are going to talk about the industrial manufacture, like industrial manufacture, ethene will react with steam. And fermentation process, if we will talk about the industrial manufacture or small scale, fermentation process, small scale preparation of alcohol, we are going to differences between these two preparations, how we can differentiate between it. So if we are going to talk about the preparation of alcohol industrially, then we can say that we can get the alcohol 100%. But on small scale, we can just get the percentage of alcohol 20%. Why? Because this reaction of fermentation is basically the exothermic. So this exothermic reaction produces heat. After some time, if the temperature rises as our ethanol is going to prepare, then automatically the temperature at when it will reach between 37 to 40, then the reaction will slows down, and after 40 the reaction will start falling down. Why? Because yeast cannot grow or respire at high temperature. They will become they are the they are the biocatalyst enzymes. So due to this reason, they will become denatured because they are protein in nature. So at small scales, 20% of ethanol is produced, 100% ethanol produced, okay. And if we will talk about small scale, 20% ethanol produced, okay. Quick production, if we are going to talk about this production, quick production, and whereas on small scale it is going to be a time taking process, little slow process or time taking process. Okay, the next, if we will talk about the differences between these two, non-biological catalysts are required for industries. Non-biological, yes. What were the non-biological catalyst? Non-biological catalyst are required. Yes, remember and memorize what non-biological catalysts are. Yes, non-biological catalysts which are used in this industrial manufacture of ethanol, the phosphoric acid, then 300 to 350 degrees centigrade the temperature, and 60 to 70 atmospheric pressure ATM are required. So the catalyst which are required is the non-biological catalyst, that is the phosphoric acid. Okay, but if we will talk about the catalyst which is required for the fermentation or a biological process, that is the yeast. So yeast is having enzyme zymase which will catalyze the reaction. So the innate biological catalyst is, in this process, biological catalyst is required. Okay, ethanol temperature, as you know, the conditions are there, 300 to 350 degrees centigrade temperature. It can take place at room temperature, pressure. But if we are going to talk about the 300 degrees centigrade temperature, 300 to 350 degrees centigrade temperature, and ATM will be 60 to 70 ATM atmospheric pressure. So these are the differences if we are going to talk about the industrial and small scale. And another very important difference, industrial scale, when we will prepare ethanol, the taste is not too good, not such good taste, okay, not good in taste as yes, as small scale production of alcohol. If we are going to compare the taste of the production through fermentation, through hydration of ethene, then we can say the taste is good. As compared to industrial production of ethanol. So this is the way through which you can check and identify the processes of both industrial and small scale. And next we will move towards the past papers to get the maximum practice. Okay, now we are going to see what kind of questions examiner is going to ask to you in the exam. So we will see. No, so this is a question which is from the past paper. How to do this question? Look at this. Ethanol can be manufactured by two different processes. Process 1, the catalyzed addition of steam to ethene, or the fermentation of glucose. So name the type of the reaction used to manufacture ethene. So what kind of reaction will take place when ethene will be prepared by the addition of steam to ethene? So it can be the type of reaction when ethene, the catalyzed addition of steam to ethene, it is called as the addition reaction. So this is the type of reaction which is used to manufacture ethene. Then write the equation for process 1. So if we are going to write the equation for the process 1, we can write the structural one, or we can write the molecular. It is not mentioned what kind of type of structures we have to write. So we will add steam in it But while we have to write the steaminate, don't forget to write the conditions. Yes, concentrated phosphoric acid H3PO4 300 to 350 degrees centigrade temp. So first name the type of the reaction used to manufacture ethene in the process 1, that is catalyzed addition of steam addition reaction. Write the equation for this process. So we have written the equation both for the, this is nothing, both for the ethene and steam to gives us one product of ethanol. We can write its equation to after writing the molecular formula. So this suggests the name for the alcohol made when the alkene C3H6 reacts. It is going to give us a propanol, and we can write the propan 1-ol or propan 2-ol. Propan 1-ol means with one carbon atom alcohol hydroxyl group is present, that is OH. So propan 1-ol or propan 2-ol we can write. Okay, now the equation for process 2 is shown. Describe 2 essential conditions required for efficient fermentation. Yes, the conditions which are required, not the enzymes he is asking. The conditions are required. Yeast, right? Absence of oxygen. Absence of oxygen is required, and temperature which we need, the very exact conditions for the efficient fermentation is 25 degrees centigrade to 40 degrees centigrade. Okay, the next question. Suggest one advantage of manufacturing ethanol by process 2, the fermentation of glucose, rather than process 1. Yes, it is a renewable source. Renewable. And then it is cheap source, cheap process. So we can write renewable sources and cheap. Then process 2, make an aqueous solution of ethanol. You can write one more about the equipments, about the batter, whatever gives you a good, because you have to suggest. So in your suggestion you can write, the answers can be 1 or 2. You can write about the compounds, you can write about the yes, about the equipments. The instruments which are used are not very highly equipped, so we can write about it as well. So process 2 makes an aqueous solution of ethanol. Suggest a method of purification that can be used to remove water from the aqueous ethanol. Yes, the process 2 makes an aqueous solution of ethanol. Suggest a method of purification. Yes, what is the method? How can we get the ethanol? Though here in this process 2, and the final we have ethanol plus water. How can we separate both of these? The process which we will use will be the fractional distillation. Fractional distillation. So guys, this is a way through which you can attempt your past papers accordingly. After getting a good understanding and good memorization, you will be able to attempt the paper very well. So this is the end of the lesson of alcohols and the preparation of properties of alcohols and the preparation of alcohols. I hope so that you have learned very well. If you have learned even a single word, so don't forget to subscribe my channel. So consistency is the key of success. Signing off, Miss Aisha Manzoor.